So now we're going to be doing Module 3, which is Research Strategies, How Psychologists Ask and Answer Questions. So this is going to be largely a lot of what you're going to be doing in research methods later on in your studies, as well as in some of your statistics courses. So I know I can hear a loud groan already, but research and research methodology is imperative to understanding psychology. So even if you choose never to go into research, it's really important to understand and be a good consumer of research, and that's why we want to be able to teach you these things. And throughout, those of you who are going to take more psych courses, you're probably going to have this lecture or variation of it multiple times before you actually enter research methods. So the way that we get the truth in psychology is using the scientific method. So it's the process by which we test our ideas about the world by setting up situations that test our ideas, so basically experiments, making careful, organized observations, analyzing whether the data fits with our ideas, and then when we look at the data, if it doesn't fit our ideas, then we modify our ideas and test it again. Or sometimes we say, well, let's try it again because maybe there was just some anomaly that it didn't work out this time. So before we can begin designing an experiment, we have to have some sort of a theory. So that's kind of like the big picture. A theory, in the language of science, is a set of principles built on observations and other verifiable facts that explains some phenomenon and predicts its future behavior. So oftentimes in psychology we get theories from other research. So people have already hypothesized various things, but you start taking it in a different, you combine different literatures and different bodies of research to develop your own theory. It may also be based on your personal experience. So nobody may have studied this yet, but you have several theories as to why something takes place. So one example of a theory is that all ADHD symptoms are a reaction to eating sugar. So a hypothesis is an informed prediction. It's a testable prediction consistent with our theory. So testable means that a hypothesis is stated in a way that we can make observations to find out if it's true. So if you had to use your theory, all ADHD is about sugar or is caused by sugar, one hypothesis would be that if a child gets sugar, the child will act more distractive, impulsive, and hyperactive. So one danger when testing hypotheses is that theories can bias our observations. Therefore, we might only select data or interpretations of data that support what we already believe. And so there are safeguards against this. Hypotheses are designed to disconfirm our theories. So when you make observations for how can we measure ADHD symptoms, we want to look at impulsivity, so we have to define these variables. So the number of times per hour a child calls out without raising their hand. Hyperactivity, we're defining that as the number of times per hour somebody jumps out of their seat. Inattention is the number of minutes continuously on task before becoming distracted. So you can see that these are all quantifiable, and so there's little room for bias to be introduced here. So the next and final step in the scientific method is replication. So replicating research means trying it again using the same operational definitions of the concepts and procedures. So even though we find our results support our hypothesis the first time around, it could just be a spurious, or a coincidence, and so we want to make sure this is actually true. And the best way to do this is not to use the same population, but to move to another lab, another area in the country, another group of children of different ethnic origin, backgrounds, etc., to make sure we're doing it in another country altogether, to make sure that what we found in one place is not just an artifact of something that's going on in that place, that it's really an artifact of, it's really kind of proving the hypothesis. You can also introduce a small change in the study, such as trying the ADHD sugar test on college students instead of elementary students to see if it would work. So here's another example of the research process on depression. So one theory of depression is that low self-esteem feeds depression, which leads to your hypothesis. So people with low self-esteem will score higher on a depression scale. And so when we administer tests of self-esteem and depression, we want to see if a low score on one predicts a high score on the other. And once we find that, we either confirm, reject, or revise our theory, and then the whole thing starts again. So we've now covered the basics, and so now we're going to talk about research goals and types: description, correlation, prediction, causation, and experiments. So one goal of research is description. So descriptive research is a systematic, objective observation of people. So these are usually done by using case studies or naturalistic observations or surveys or interviews. And the goal of descriptive research is to provide a clear, accurate picture of people's behaviors, thoughts, and attributes. So a case study is observing and gathering information to compile an in-depth study of one individual, which in certain cases can be very beneficial, but it's very hard to generalize because, there may be something with this individual that's very special and doesn't generalize to all people who have similar characteristics. Natural observation is gathering data about behavior by watching but not intervening. So this is by watching somebody in an environment when they often don't know they're being watched. Obviously you have to have ethics approval for this. And then surveys or interviews are having people report their own attitudes and behaviors. So a case study is examining one individual in depth. A benefit of this is it can be a source of ideas about human nature in general. So cases of brain damage have been suggested the function of different parts of the brain. So like Phineas Gage got a pole in his head, and therefore he had different problems, and so by doing that they were able to hypothesize that based on his brain damage that the damage in this area caused the problems that he was experiencing. However, the danger is that overgeneralization from one example, that he got better after tapping his head, so tapping must be the key to health. So maybe it worked for him, but that's not necessarily what's going to work for everybody else. So natural observation, as we mentioned, is observing people, natural behavior. So we watch, we take notes, and we try not to change anything. And so this method can be used to study more than one individual and to find truths that apply to a broader population. You'll often see it done with children through a two-way mirror, as you're seeing in the picture here. Surveys, we love surveys in psychology. A lot of you who are doing online studies will be doing a lot of surveys. And survey is a method of gathering information about many people's thoughts or behaviors through self-report rather than observation. Keys of getting useful information are being careful about the wording of questions so they're not ambiguous or they're not leading in any way, and to only question randomly sampled people, because depending on what your question is, sometimes you need specific individuals. Like you might only want to sample women, you might only want to sample somebody from a certain ethnic group. So here's an example of how wording can bias somebody. Question, do you have motivation to study hard for this course? Do you feel a desire to study hard for this course? And so based on that, people might respond differently. It's kind of like, how fast was the car going when it crashed into the wall? By using the word crash, it implies that the car was going fast, versus how fast was the car going when there was impact or when the car hit the wall. So oftentimes what we do in psychology is we take a sample. So we have, when we do surveys, we want to talk about, this is how women respond, but obviously we can't sample all, X billion number of women in the world, so we have to take a sample. So if you want to find out something about men, obviously you can't interview every single man on the earth, so sampling saves time. You can find out the ratio of colors in this jar by making sure they're all well mixed, randomized, and then taking a sample. So we would assume that by taking a sample it was representative of the entire population. Now, that's only done in random sampling. So I'm sure that if we looked at the population, which is the jar on the left, and then we looked at the sample, there might be some differences, but overall it would be very similar proportion. So random sampling is a technique for making sure that every individual in a population has an equal chance of being in your sample. So the selection of your participants is driven only by chance and not by any characteristic alone. But often that doesn't work. So for example, we do a lot of surveys online. So the sheer fact by doing it online means we're probably excluding people who don't have computers, and generally very young children and individuals who are much older who don't use the internet too much. So in doing many descriptive studies, we might find a correlation, and that's the observation that two traits or attributes are related to each other, thus they are co-related. So it's a measure of how closely two factors vary together, or how well we can predict a change in one by observing a change in the other. So, for example, in a case study, the fewer hours the boy was allowed to sleep, the more episodes of aggression he displayed. In a naturalistic observation, children in a classroom who were dressed in heavier clothes were more likely to fall asleep than those who were wearing lighter clothes. And in a survey, the greater number of Facebook friends, the less time was spent studying. So these are just examples, they're not actually necessarily true. So one way to kind of visually depict correlations are using scatter plots. You probably did this in high school where you have, your X and your Y axis. So if we plot shoe size and height, shoe size on your X axis, height on your Y axis, here we see a very strong positive correlation between the two, which just logically makes sense. As people's shoe size increase, so does their height. A negative correlation. So to determine, well, we'll talk about this in a second. A negative correlation is Facebook and studying. So the number of hours spent per week studying is on the y-axis. The number of Facebook friends is on the x-axis. And you'll see that the number of friends decreases significantly the number of hours spent studying. And if you draw a line through the middle of all those dots, you'll see that it's a negative correlation. So factors can vary together. They can either vary in a positive direction or in a negative direction. So if it's positive if the line falls to the right. If the line falls to the left, then it's a negative correlation. So as one number goes up, the other number goes down. The correlation coefficient is a number representing the strength and direction of the correlation. So we want if we want a strong correlation, we want the number to be as close to 1 as possible. So you see on the left and the right, on the left, bottom left, a perfect positive correlation. So as one increases, the other increases proportionally. The middle is a perfect negative correlation. So as one increases, the other decreases. And then you'll see on the right, there's no correlation whatsoever. So there's no way that you can even draw a line through that. If you drew a line, it would really be parallel to the x-axis, indicating that there's no relationship between the two variables. So it's always important to do correlations using scatter plots because we couldn't necessarily see this graphically. So what you do is you plot the x and y axis, and then you find kind of the slope or the best fitting line between, which is the slope, and that shows you the correlation. So if we find a correlation, what conclusions can we draw from it? So let's say we say that there's a positive correlation between two variables like ice cream sales and rate of violent crime. How do we explain this? So as ice cream sales increase, so do the rates of violent crime. So are criminals ice cream eaters, or what's going on? So we have to also remember that correlation is not causation. What likely happened in the previous example is that we know that crime seems to be increased on hot days, and on hot days people eat more ice cream. Therefore, both of those things are probably correlated with the temperature, and therefore they appear to be correlated with one another. So people who floss more regularly have less risk of heart disease. If this data is from a survey, can we conclude that flossing might prevent heart disease, or that people with heart habits also floss regularly? People with bigger feet tend to be taller. Does this mean that having bigger feet causes height? No, but the two do vary together. So if self-esteem correlates with depression, there's still a number of possible causal links. Self-esteem could cause low self-esteem could cause depression. That's one possibility. Depression could cause low self-esteem, or distressing events or biological predispositions we talked about previously could cause low self-esteem and depression. So there could be a third variable that mediates or moderates the relationship. So how do we find out about causation? And we do that by experimentation. So this is when we manipulate one factor in a situation to determine its effect. So this is much more of an experimental design. So removing sugar from the diet of a child with ADHD to see if it makes a difference. And in the depression self-esteem example, trying interventions that improve self-esteem to see if they also cause a reduction in depression. So random sampling and random assignment are two terms that sound the same, but they're actually meaning something different. Random sampling is how you get the pool of research participants that you need. So remember, if we think about our jar, random sampling is just taking out a random sample of beads from the jar. Random assignment is how we control that our two groups are equal. So if we have an experimental and a control group, for example, we'd want to just give people a number and randomly choose their number to put them in the experimental or the control group. And that way, generally, if we average out characteristics like gender, weight, age, things like that, they're usually similar across the two conditions because we just assign them randomly. Now, you've probably all heard about the placebo effect. So how do we know that when we do a manipulation in an experiment, that our experimental group doesn't show an effect because they expect to experience it? So for an example, an experimental group gets a new drug while the control group gets nothing, yet both groups improve. Do you know why? Because of the placebo effect. So it's experimental effects caused by the expectations of the intervention. And I've done pharma research before in the pharmaceutical industry, and we've seen this time and time again. People in the control condition, unbeknownst to them, get some sort of a sugar pill, and we do see improvement in their symptomology. Now, where we can tell the difference in whether the agent is working or not is we subtract that placebo effect from the actual those who are actually getting the medication. And if the medication is actually working, there will be a difference between the two of them. And if the medication is not working, the two of them will be the same. So in order to work with the placebo effect, control groups may be given a placebo or an inactive substance or another fake treatment in place of the experimental treatment. The control group is ideally blind to whether they're getting real or fake treatment. So if you tell people they're getting fake treatment, it's really pointless to even give them fake treatment because they know it's fake. Many studies are double-blind, therefore neither the participants nor the research staff knows which participants are in the experimental or control groups. And that's important because as the experimenter, you may treat people differently if you know what condition they're in. And this way, if you're blind to it, there's no way that you can bias the results. So I've already used the term control group. If we manipulate a variable in the experimental group, then in order to see the effect, we have to have a control group where we're not manipulating anything. And so the control group is the same in every way except for the one variable we're changing. So for example, two groups of children have ADHD, but only one group stops eating refined sugar. The group that continues eating refined sugar is the control group. The group that stops eating refined sugar is the experimental group. So how do we make sure that the control group is really identical in every way to the experimental group? And that's by using the random assignment, whereby we randomly select some study participants to be assigned to the control group and some to the experimental group. So we're not doing any kind of self-selection, which could lead to bias. So just to give you a sense of what we're calling these variables, I hopefully are not asleep quite yet. The variables that we're manipulating independently of the other variables are called the independent variables. So this would be whether kids are eating sugar or not is the independent variable. Then the dependent variable is what we, is the outcome measure basically. So if we test the ADHD sugar hypothesis, as I mentioned, the sugar and the variability of the sugar is the independent variable, and then the symptoms of the ADHD and how that's affected by either taking away the sugar or keeping it there are the dependent variable. Other variables that might have an effect in the dependent variable are called confounding variables. So did ice cream sales cause a rise in violence or vice versa, as we talked about? There actually might be the confounding variable, which would be temperature. Interestingly, similarly, there's the correlation versus causation debate for the breastfeeding intelligence questions, because studies have found that kids who are breastfed on average test higher intelligence than those who are bottle fed. So therefore, can you conclude that those breastfeeding causes higher intelligence? While I, who nursed each of my children for over a year, would like to think that's the case, it's not necessarily the case. There's at least one confounding variable, which is genes, and then the intelligence test scores of the mothers might be higher in those who choose to breastfeed. So how do we deal with this confounding variable? Hint, we do an experiment where we control for these things. So in an actual study, women are randomly assigned to be in a group which breastfeeding was promoted. The independent variable is being the breastfeeding is promoted or not promoted, and the dependent variable is the intelligence score for age 6. So just a brief summary of the types of research we've already discussed. So descriptive is used to observe and record. Nothing is manipulated, and there's no control, so they can be misleading, and we can't really make generalizations. Correlational research is to detect naturally occurring relationships and to assess how well one variable predicts another. Again, we're not manipulating anything. but we can't determine any cause and effect, that one variable actually predicts another or causes another, just that we know the two variables vary together. In an experimental design, these are used to explore cause and effect, where we manipulate one or more factors, such as we manipulate the independent variable, which then we have the dependent variable as our outcome. However, it's sometimes not possible for practical or ethical reasons, and the results might not generalize to other contexts. For example, I study suicide and sex offending, and I can't randomly assign people to be sex offenders or not, or to make suicide attempts or not. These are already, fait accomplis, and therefore we have to deal with the populations as they already are, and people can't randomly be assigned to those conditions. Now, just a brief stats lecture here. I won't bore you too much, but some of the terms that you might hear are mean, median, and mode. Hopefully you've talked about these in high school before. Mean is the sum of scores divided by the number of scores, so the average. The median is the middle person or 50th percentile. So if you cut the sample in half, what did the 50th percentile person get? The person right in the middle. And mode is the most common level or number or score that in your sample. So these are all measures of central tendency. So you have to make sure that you use the appropriate one when describing your sample. For example, if you have data that's very skewed and you have a few outliers, therefore your mean might not represent most of your sample. So in this slide, you can see on the left is where we find most of the people, but because we have some people that are really high in terms of family income, they increase the average above what the majority are. So in this case, the median would probably be a more accurate representation of the groups. Now, measures of variation, we want to look at how spread out are the scores. When we do that, we talk about the range, and that's the difference between the highest and the lowest scores in a distribution. So you can see, and then in certain cases, there's a large range that most people, are scoring, really high or really low. But in some cases, a lot of people are grouped around a certain point, and therefore the range is restricted, and it's just kind of somewhere in the middle. So if we look at kind of test scores, very few people are getting 100 or 0. A lot of people are kind of getting in the 70s and 80s, so the range there would probably be restricted. And the standard deviation is a calculation of the average distance of scores from the mean. So you can see the purple line here is a large standard deviation, and the orange line is a small standard deviation because the results are grouped very closely around the mean. So when we look at distributions, we want to make sure that our statistics are generally based on normal distributions, which means that the majority of the scores are centered around the mean. And that's called kind of the bell-shaped or normal curve. When the distribution is skewed, that means that the scores do not fall around a mean, but might be positively or negatively skewed, as you can see in the purple line there. So you can see here that scores of intelligence at high school and at college are somewhat different, and people are scoring higher. The mean is higher in those among college students. So drawing conclusions from data, are the results useful? So we have to think about reliability to make sure that the results that we have can actually be replicated and are valid to use in another population. So we have to make sure that we have used a non-biased sample, that the distribution is consistent, that it doesn't vary too much, and that we have a lot of data points, and so that we don't try to make generalizations about an entire population based on very few data points. Then we also have to look at significance. Could the results have been caused by random chance or variation between the groups? When we have statistical significance, that means that there's less than 5% chance that the difference between the experimental and the control group is due to chance. So there's still a 5% chance, but we're 95% sure that it's due to the manipulation that we've made. Therefore, when we know that our data is valid and reliable and we have statistical significance, we're more apt to be able to make a causal conclusion based on our data.